Okay, chemistry. Let's see if we can do this. I'm going to go through the slides here of our next lesson, stoichiometry. Doesn't that sound fun? So get out your notes that I've given you and you're going to fill them in. If you do not have the ability to print them, then have them next to you on a device and write things down. Okay, stoichiometry, what does it mean? It is the mathematics of the balanced equation, calculations of quantities of materials consumed and produced in chemical reactions. Okay, that's what the definition is. So there are two types of stoichiometry. Composition stoichiometry, which is the mass relationships of elements in a compound, and reaction stoichiometry. Okay, well, let's talk about this one first. This is the mole conversions. Okay, we've done that. And then reaction stoichiometry is the mass relationships between reactants and products in a chemical reaction. Now you know chemical reactions, so we can do this kind now. So let's see how this goes. First, let's consider a recipe for sugar cookies. Okay, this isn't on your notes. This is just to show you what we're gonna do. Here's a recipe. 2 cups of sugar, 1 cup of butter, 2.5 cups of flour, 1 egg, 1 teaspoon vanilla, and 24 cookies. Okay, so we could kind of write it as a chemical reaction. You're gonna add all these things together and it's gonna yield 24 cookies. Don't try this at home, it's not a real recipe. So, what is the ratio between sugar and butter? 2 to 1. 2 cups sugar to 1 cup butter. What is the ratio between sugar and cookies? 2 to 24. 2 cups sugar, 24 cookies. So if you have 4 cups of sugar, how much butter would you need? 2 cups. If you want to make 48 cookies, how many eggs would you need? 2 eggs. What if I gave you the sugar measured in grams? What would you have to do? You would have to convert the grams to cups. That right there is stoichiometry. Okay, that's what we're going to do. So now let's look at a chemist's recipe instead of a recipe for some cookies. A chemist's recipe is a balanced equation. So here we've got a balanced equation. This is on your notes now. And instead of cups, this recipe is going to be measured in moles. So if you have 8 moles of NH3, how many moles of water would you make? 12. Because if you have 4 moles, you make 6 moles of water. So if you have 8 moles, you're going to make 12. If you have 8 moles of NH3, how many moles of oxygen would you need? 10. Okay, we're looking at the ratio of the coefficients. What if I gave you the NH3 in grams? What would you have to do? Convert it to moles. Just like in the cookie recipe, you would have had to convert the grams to cups if you were given it in grams. You know how to convert things to moles. We've done this before. So in stoichiometry here, you will see questions such as, if you start with an amount of A, how much C will be produced? If you start with an amount of A, how much B will you need? If you produce amount of C, how much D will be produced? That's the kind of question we're going to answer here. So let's review. Now this is on your notes. Okay, reading the compounds. We're going to fill this chart in. This is on your notes. NH3 is 1 nitrogen atom and 3 hydrogen atoms. O2, 2 oxygen atoms. H2O, 2 hydrogen atoms, 1 oxygen atom. NO, 1 nitrogen atom, and 1 oxygen atom. So that's how we read those. And now the next section, we're going to actually calculate the molar mass of these. How do you calculate molar mass? What do you use to find the molar mass? You use your periodic table. So for NH3, you're going to look on your periodic table and see that N is 14.01 and H is 1.01, and you're going to add together 1 N and 3 H's, and you're going to get 17.04 grams per mole. It's from the periodic table. That's where you're getting that. O2, you're going to look on your periodic table and see that O is 16, and you're going to say 16 plus 16, and you're going to get 32. H2O, 2 H's and 1 O, and you should get 18.02. Okay, we're going to round these to 2 decimal places. And then NO, you're going to look on the periodic table, 1 N, 1 O, and you should get 30.01 grams per mole. Those come from the periodic table. Now, we are going to read the balanced equation. This is 4 nitrogen atoms and 12 hydrogen atoms. Okay, 4 NH3. Once we put a 4 coefficient out in front, that means we are going to have 4 of NH3s. We're going to have 1 NH3 plus 1 NH3 plus 1 NH3 plus 1 NH3. So that gives us 4 N's and 12 hydrogens. 5O2 gives us 10 oxygen atoms. 6H2O gives us 12 hydrogen atoms and 6 oxygen atoms, and 4NO gives us 4 nitrogen and 4 oxygen. You need to know that because when we do the stoichiometry stuff. Okay, the balanced equation also tells us the ratios between the reactants and the products. 4, 5, 6, 4. This is called a mole ratio. Okay, these are the coefficients out in front. 4, 5, 6, 4. How many mole ratios can you find for this reaction? Well, we could say 4 NH3s to 5 O2s, 4 NH3s to 6 H2O, 5 oxygen to 6 H2O, 6 H2O to 4 NO, 5 O2 to 4 NO, 4 NH3 to 4 NO. Okay, we can find all of those different ratios. So now we're going to talk about conversion factors. We've talked about conversion factors before, but we're going to have a new conversion factor now. We're going to have a conversion factor of moles to moles. We haven't used that before. This is where we're going to compare 2 compounds in the reaction. And they're both going to be measured in moles. Moles to moles of the balanced equation. Okay, here's our old conversion factors. Grams to moles or moles to grams, moles to particles, particles to moles, and liters to moles or moles to liters. Where did we find our grams to moles or moles to grams? From the periodic table. What did we do with moles to particles or particles to mole? That's Avogadro's number. And liters to moles or moles to liters, that was the 22.4 liters to moles. Okay, those are the conversion factors that we've already used. The mole, remember this? The mole is at the heart of the matter. We've got mass, we've got number, we've got liters. If it's mass, then you use the periodic table. If it's number, then you use Avogadro's number. That would be like the number of atoms or the number of molecules or the number of particles or the number of formula units, number of anything except for liters, and that you're going to use 22.4. Remember, the mole is the heart of the matter. Everything goes through the mole. You start at the left with what you're given, and you convert to moles if it's not already in moles, and then you keep going. Now we're going to have another thing. We're adding this in, moles of unknown to moles of given. And look, those are moles to moles of the balanced equation. So then we're going to convert moles of given to moles of unknown. And we're going to end on the right with unknown in moles and convert it to the unit of the unknown. So then we're going to go back to whatever unit. So if we start with grams, we're going to convert it to moles. Then we're going to convert the moles of given to moles of unknown. And then we're going to convert those moles of unknown back to grams. Okay, so now we have, once we go back into the mole, then we're going out. We're going to go out to the mass or out to the number or out to the liters. So we've added another heart here. We're adding another step. There should be a picture, a handout of this that I'm attaching to this lesson. So if you don't want to write this all in your notes, you should have, there should be a paper. Or you could write things on that paper. All right, so let's look at an example. For most stoichiometry problems, you're going to need to either balance the equation, write the equation, and then balance it, or you might be given a balanced equation, but you can't start the problem until the equation is already balanced. Okay, it's got to start with a balanced equation. So you've got to have that first. If you are not given a balanced equation, then you got to do that first. So let's look at this one that we've already been looking at. This is a balanced equation. If you look at all the different parts, there's 4 n's on this side, 4 n's on this side. There's 12 h's on this side, 12 h's on this side. There's 10 o's and there's 10 o's. So everything is balanced. How many moles of water are produced if the reaction begins with 7.50 moles of NH3? All right, we're going to start on the right with what you are given. What are you given here? You are given 7.5 moles. I am going to go back . To the whiteboard, and I'm going to say you are given 7.5 moles of NH3. That's what you're given over 1. You always write what is given here. Then you're going to change it to moles if it's not already in moles. Well, lucky us, it's already in moles. So now we're going to take moles of what we're given on the bottom, moles known, and moles unknown on the top. That's what we're trying to find. And that's going to equal, because now this is going to cancel with that, and we're going to be left with that, and our answer is going to be moles of moles of H2O, which is what we're looking for. So we've got to decide what we're going to put in here. And you're going to look at your equation, and you're going to say what you're given. Moles of NH3 is 4, and moles of H2O is 6. That's from our equation. Here's our equation. there's our equation. So here's our moles of NH3. Here's our moles of H2O. Now we're just going to put this in our calculator and do this problem, and you should get 11.3. So let's see if I can go back to sharing my screen. And let's see if we did it right. Okay, we got 7.5 moles of NH3. And then we're going to put what is known on the bottom, unknown on top. Those are going to cancel. We're going to put on the bottom the 4, on the top the 6. Do this in your calculator, and you should get 11.3 moles of H2O. 3 sig figs in the given, so 3 sig figs in the answer. That's what we're doing right here. Okay, let's try another one. If 25.0 moles of H2O are produced, how many moles of NO will also be produced? All right, so let's see. We're going to write what's given, which is 25 moles of H2O on the right, and then we're going to put that on the bottom, what's unknown, which is NO on the top. We got to put in our conversion factors there from our equation, from our balanced equation. So we're going to put, those are going to cancel. We're going to put 6 or 4 NOs and 6 H2Os. Put that in your calculator and you'll get 16.7 moles of NO. 3 sig figs in the given, 3 sig figs in the answer. Okay. Oh, look at this one. Magnesium reacts with hydrochloric acid. If 7.8 moles of hydrochloric acid reacts, how many grams of MgCl2 will be produced? So before we can do this, we actually have to, let's see. We actually have to write this equation before we can do this problem. Okay, magnesium reacts with hydrochloric acid. So what is magnesium? Mg. What's hydrochloric acid? HCl. So then we've got Mg, and it says MgCl2 is what is being produced, but also we have hydrogen, which always comes in twos. Okay, I'm going to see if I can do this on my whiteboard again. Let's see if this will work. So we've got magnesium, which is reacting with hydrochloric acid. And it tells us that it makes MgCl2. But look, we had hydrogen over here. So we're going to have hydrogen over here. Hydrogen is one of those diatomic atoms or elements that always comes in twos. So here's our equation, but we need to make sure it's balanced. Is it balanced? No, it's not, because look, there's 2 chlorines over here and only 1 here. So if I put a 2 here, now we have 2 chlorines and we have 2 hydrogens and we have 1 magnesium. So everything is balanced. Now this is balanced. So we're going to write what we're given, which is 7.80 moles of hydrochloric acid over 1. And it says how many grams of magnesium chloride will be produced. So now we're going to have to go a step further. But let's start with this. We're going to put moles of hydrochloric acid and magnesium, moles of magnesium chloride on the top. And we're going to put in our conversion. This should be moles. We're going to put in our conversion factors from our equation. So we've got 2 goes there and 1 goes there. Those are from the balanced equation. And now this is going to give us moles of magnesium chloride, but the problem is asking us for grams of magnesium chloride. So we're going to have to put moles of magnesium chloride down here and grams of magnesium chloride up here. And this number that we put in here is going to be from the periodic table. Look on your periodic table, 1 magnesium, 2 chlorides, and you should get 95.21 grams per mole. Now, you can do this problem on your calculator. Multiply the top, divide by the bottom, and you will get, we need to have 3 sig figs, so you will get 371 grams of magnesium chloride, and that is going to be the answer. So, let's go back to my screen. And see if we did it right. Okay, there's our balanced equation. We got what we're given. We put moles over moles, then moles and grams, put in what we know from the balanced equation, put in the grams from the periodic table, do the problem on your calculator, and you should get 371 grams of grams of magnesium chloride. Okay, there were 2 conversion factors here. This was different than the one that we did first. Different. Okay, partner challenge. How many moles of mercury 2 oxide are needed to produce 125 grams of oxygen? So we're going to have to do this problem on we're going to have to first draw or make the equation. We've got mercury 2 and we've got oxygen. And oxygen, if you look on your periodic table, has a charge of -2. So mercury oxide is HgO. So, and it's telling us that mercury oxide to produce oxygen, and we also will have to have mercury. So is this balanced? No, it is not. There's 2 oxygens here, so we got to put a 2 here, and we have to put a 2 here. Now it's balanced. It's a balanced equation. So write what we know, what we're given, 125 grams of oxygen. Do is change it to moles. Okay, you got to change it to moles if it's not already in moles. So where do we find this number from? Moles is always 1, grams is from the periodic table. Look on the periodic table for oxygen, and you need 2 of them. So this is 32.00 grams. Now we're going to, if you see here, that's going to cancel with that. So now we're going to put moles of oxygen on the bottom. And then what we're looking for how many moles of mercury oxide. Mercury oxide is HgO. Moles of mercury oxide. These numbers we're going to find from our balanced equation. Oxygen has a coefficient of 1. Mercury oxide has a coefficient of 2. So now this is going to cancel with that, and we're left with moles of mercury oxide, which is what the problem is asking us for. So go ahead and do this problem on your calculator, and you should get 7.81. moles of mercury oxide. Okay, let's go back to the PowerPoint and see if we did it right. Mercury oxide, there it is. Put in the numbers, all those things cancel. So our units, don't be afraid to write this all out. If you write it out neatly in a line, everything's going to cancel and you're going to end up with the right answer. Put in what you know, these grams from the periodic table, these numbers from the balanced equation, and then do it on your calculator. Okay, when sodium chloride reacts with silver nitrate, sodium chloride precipitates. What mass of sodium chloride is produced from 75.0 grams of silver nitrate? All right, we got to first write this equation. What is sodium chloride? Sodium chloride is NaCl. That's salt. And it's reacting with silver nitrate. So you need to make silver nitrate, AgNO3. You're going to find that on your polyatomic ion chart. And the silver chloride precipitates. So it's going to end up as this. Okay, sodium chloride. Whoa. Sodium chloride plus sodium chloride reacts with silver. Sodium chloride reacts with silver nitrate and it makes silver chloride, and then you're going to be left with NaNO3. It's a double replacement here. And we got to check to see if it's balanced. Is it balanced? It is balanced. So what do we start with? We start with 75 grams of silver nitrate, and we're going to have to change it to moles. You always change it to moles. 75 grams of silver nitrate changes to moles of silver nitrate. Then we put moles of silver nitrate on the bottom, and we have, we're looking for silver chloride, so we put moles of silver chloride on the top. And it's asking us for the mass, so we're going to have to change the moles of silver chloride to grams of silver chloride. So where do these numbers come from? Well, first let's show that they all cancel out, and we're left with what we're looking for. This first number down here, we're going to get from the periodic table. Silver, N, and 3 O's. Then these moles we're going to get from our balanced equation, which the coefficients are all ones, so they're both going to be ones. And then over here, these grams are from the periodic table. So we're going to find that from the periodic table, and we're going to do this whole problem on your calculator, and you get 63.3 moles of silver chloride. Okay, now try one on your own. In the combustion of methane with oxygen gas, so here's methane and oxygen gas, how many moles of carbon dioxide are produced from 105.5 grams of methane? In the combustion, remember that you're left with H2O. So this is our problem, but look, it says hint, you have to balance the equation first. This equation is not balanced. There's 1 carbon on either side, but there's 4 hydrogen here and only 2 here. There's only 2 oxygen and there's 3 oxygen. So you have to balance this by putting 2 2's there. Now we've got 4 oxygen, 4 oxygen, 4 hydrogen, 4 hydrogen, and 1 carbon. So now everything's balanced. So start with what you're given. 105.5 grams of methane. You got to change that to moles. Then you're going to put moles of methane on the bottom. That's what we know. And what we're looking for are moles of carbon dioxide. That's what you're going to put on the top. You're going to cross these off. This number down here comes from the periodic table. These two numbers come from the balanced equation, which are both ones in this case. You're going to put this in your calculator, and you're going to get 6.573 moles of carbon dioxide. And that is what it was asking you for. Okay, do you see a pattern? Reading the units. Okay, look at this. This is what you're going to write at the end of that first page. Reaction stoichiometry. Grams to moles to grams to moles to moles to grams to moles. Always in between the two compounds are the moles to the moles. Okay, the moles to moles are always in between the two compounds. I think we might, you can start and end anywhere along the path that the problem dictates. So whatever the problem gives you, if it gives you moles, then you don't have to do this section here, okay? But you will always have the mole to mole conversion factor between the two compounds. That is always going to be the case. Moles to moles between the two compounds. Rarely, if ever, are chemicals handled in quantities or measurements of moles. So there's almost always calculations to be made. Okay. I think we're going to stop right here, and I'm going to let you yes, we're going to stop right here, and I'm going to let you work on some homework, and then we'll come back tomorrow with another video on this.